My name is Ebenoy Amadi. So for the first question, what are the advantages of using Booth's algorithm? The first advantage is that it allows for easy use of signed numbers, and this is an advantage because unlike regular multiplication, it can consistently multiply and can maintain the sign regardless of what number is negative. Two, it reduces the number of adds, and this is an advantage because it makes it more efficient and more and quicker than the normal process of multiplication. Three, it's the Booth algorithm is simple and not very complex to implement, meaning that it's easier to get a better understanding and it's easier to implement into applications. The second question, algorithm affects instruction count because depending on how you build your algorithm determines how many instructions it can handle, and it affects the CPI because the amount of instructions it can handle also relate to how many cycles it's going to need to process those instructions. For programming language, depending on what type of programming language affects how much instructions it takes to do a particular thing, and it affects the CPI because if you use something like Python, it'll take more instructions to do the same thing in C++. So it's going to take more cycles to process Python. As a compiler, relating to the last example, the different programming languages affect how many cycles it takes for the compiler to break it down to how many cycles it's going to take it down. How many cycles it takes to break it down to machine code, as well as for the instruction counting for a compiler. The different programming language is going to affect the compiler in different ways, so it's going to also affect its instruction count. In terms of the ISA, affecting the instruction count, the ISA is going to determine how many instructions it can how many instructions it takes to process something from the machine code from the compiler, i.e. like if the ISA doesn't have like a multiplier, it's going to take more instructions to process that code, and so that affects the relations with how many clock cycles it takes. So in using the same examples, because it's going to take more instructions, it's going to take more cycles, and the processors affects the CPI because how you build your hardware is going to affect how fast how fast it can cycle through instructions. Thus, also how you build your processor is going to affect how much the clock cycle is. And with technology, the newer technology is going to always make it it's always going to speed up the clock cycle. So and older, it's going to be slower. So technology can easily really determine how fast or slow the clock cycle is going to be. The ISA stack is not the best ISA ever created because unfortunately load store is the better one. That is because load store uses registers unlike stack, thus making it faster, more efficient and versatile. Also ISA takes up takes a lot more instructions than ISA takes a lot of instructions to do. Takes up a lot of instructions because of the nature of it. Not to mention it takes not to mention it's much more complicated to use than load store, because is the more complex the algorithm is, the more instructions it's going to take to do the same thing in load store. And the last reason is that in the stack, that you can easily lose intermediate values if you don't do it properly, whereas in load store intermediate values can always be saved, thus making it a lot more efficient to make programs with. And in the last one, read after read is the least problematic pipeline, because it doesn't actually affect the value in the register. It doesn't affect the value in the register. Thus, nothing really needs to be done if it occurs. Unlike the other pipelining hazards. So read after read is barely doesn't really affect the program, unlike the other pipelining hazards.